Good afternoon, everybody. This is Dr.T.S.RAVI, Head and Associate Professor from PB Siddhartha College of Arts and Science. Today, I am going to illustrate about the white box testing or glass box testing in software engineering. So, white box testing or glass box testing is a testing which is used to verify the entire logic of the source code. This white box testing is used to find the anomalies in the source code when the programmer is writing. So the first part is basic path testing. So this was proposed by the Tom McCabe. Basic path testing based on the control structures of the program. So the crucial components includes flow graph notation. A flow graph is a control flow graph. Is a section of code displayed as a graph along with the possible paths that could be executed. The second component is flowchart and flow graph. The flowchart is a graphical representation of an algorithm. Here we have various structured constructs in a flow graph form. The first one is sequence. After first node is verified, then the control is going to the second node. The second structure is if. So once the node is identified, based on the condition, the traversal is going on either left side or right side. Next component is while. First of all, the control is entering into the loop, and the loop is iterative till the termination condition occurs. Until here also the control enters into the loop. Once the termination condition occurs, the control is exit from the loop. The next one is the case statement, whereas the user is privileged to one option when several options are possible, whereas the source code related to that option will execute. So these are all the basic structured constructs in a flow graph form. Now coming to the flowchart. From the flowchart, we need to derive the flow graph. First of all, the user comes to the decision condition 1. So the decision conditions have two options. One is true, another one is false. If the condition is false, then the control goes to 11 and it stops the execution. If true condition is encountered at decision 1, the control goes to 2, and after 2 again the control goes to the decision condition 3. So if the condition is correct, the control goes to 4, 5, 10, and from 10 to the control goes to 1, and 1 to the control goes to 11, and it terminates at 11. So if the condition is false at decision condition 3, the control goes to the decision condition 6. Again from decision condition 6, if the decision goes to 8, if the decision condition is true, from 8 to 1, 8 to 9, 9 to 10, 10 to 1, 1 to 11. This is one more path. The decision condition is false at the decision node 6. The control goes to 7, from 7 to 9, 9 to 10, 10 to 1, 1 to 11. So here I am exploring all the possibilities. I am exploring all the possibilities and all the possible paths in a flowchart. So the possible paths are path 1 from 1 to 11. From 11, one path exists. The second path is 1 to 2, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 10, 10 to 1, 1 to 11. That is second path. And the third path is path 3, 1 to 2, 2 to 3, 3 to 6, 6 to 8, 8 to 9, 9 to 10, 10 to 1, 1 to 11. And the last path, path 4 is 1 to 2, 2 to 3, 3 to 6, 6 to 7, 7 to 9, 9 to 10, 10 to 1, 1 to 11. So here I encountered 4 independent paths in a flowchart. From the flowchart, I need to derive the flow graph. Here I am deriving the flow graph for the given flowchart. Since 1 is the starting node, I am indicating the starting node with a circle. From 1 to the path lies 2 to 3. From 1 to the path lies 2 to 3. So I am considering 2 to 3 is another node. From 3 to the path goes to 4 to 5. The 4 to 5 is another node. From 3 the path goes to 6. 6 is another node. From 6 to the path goes to 7. 7 is another node. From 6 to the path goes to 8. 8 is another node. From 7 and 8 the path goes to 9. 9 is another node. From 4, 5 to the path goes to 10. From 10 to the path goes to 1. From 1 to the path goes to 11. Based on the navigation, based on the navigation of the flow chart, I'm writing the flow graph. So after flow graph is formulated, we need to identify the regions. Suppose if I laid the color in between the 6, 7 red, suppose if I laid the color between the node 6, 7, 9, 8 as red, we can call it as a R3. Similarly, I'm laying the color between the nodes 2, 3, 6, 8, 9, 10, 4, 5, 2, 3. Green. That is all R2. I'm laying the color between the 10 and 1 as yellow. So the entire color is white canvas. So totally I am identifying 4 colors. That is means 4 regions. The entire white color is one region, R4. R3 is red, R2 is green, and R1 is yellow. So I am able to identify 4 regions from the flow graph. In this case, we have we, from the flow graph, we need to identify the cyclomatic complexity. The formula for the cyclomatic complexity is V of G is equal to E minus N minus 2. That is one formula. The second formula is V of G is equal to P minus 1. E means number of edges. So here I have 9 edges, 11 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 edges. Nodes. How many nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 nodes. 2. 2 is a constant number. Whereas the cyclomatic complexity is 11 edges minus 9 nodes plus 2. 2 plus 2. That is equal to 4. Or we can identify the cyclomatic complexity with predicate nodes also. Here I have 3 predicate nodes. 3 is one predicate node, 6 is one predicate node, and 1 is one predicate node. Totally, we have 3 predicate nodes where the decision is made at the predicate nodes. 1, 3, 6 are the 3 predicate nodes. So 3 plus 1. The cyclomatic complexity is 4. So from the given flow chart, we need to identify the flow graph. From the flow graph, we need to identify the cyclomatic complexity. So building the source code. So I am writing the source code. I am writing the source code in Java for identifying the for finding the average marks of the students. So in this case, we need to know the syntax. Syntax means set of rules of the Java programming. Semantics. Semantics means meaning. The sun rotates around the earth and the earth rotates around the sun. The second one is correct. The first statement is not correct. Even though both the statements are look similar. So we need to understand the semantics, meanings also. Meaning also. Next, pragmatics approach, practical approach. Loop structures. If loop, for loop, while loop, repeat until loop, case statements. We need to understand all the looping structures. So then only we can write the program. Then only we are able to in a position to write the program. So I am writing the source code to identify the average mark of the student in Java. So in order to understand the source code, I need to understand the syntax, set of rules, semantics, meaning of the rule, and pragmatics, practical approach. Then only I can write the program. So here a program is written using Java for finding the average of the subjects. And we are able to identify the division also. Either it is first division, second division, or third division, etc. Next, graph matrix is also one of the important aspects of the white box testing. Here, a flow graph is given. Totally, I have 5 nodes 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7 edges also. Okay. So I need to write a graph matrix for the flow graph. So I am taking the nodes as a square matrix 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. An edge is labeled between the 1 and 3 with the name A. So in between the 1 and 3, I am labeling edge A. Between 3 to 4, between the 3 to 4, I have edge B. From 3 to 2, I have edge D. So the label edge, I'm writing the label edges in a matrix. From 4, I have a edge to node 2 with C. Similarly, from 4, I have an edge F from 4 to node 5. F. Next, I have no edges from node 2. Saying about 5, from 5 to 2, I have a edge G. So 5 to 2, I have a edge G. Similarly, from 5 to 3, I have edge E. So I am able to write the graph matrix for the given flow graph. Next, control structures. We need to understand all the control structures. So condition testing, data flow testing, loop testing, different types of control structures. Here, simple loop. Here I am demonstrating the simple loop. So first of all, the, the control goes to the condition. If the condition is true, I have one edge labeled. The condition is false, I have one more edge labeled. Concatenated loops, nested loops, inside a loop. If the inner loop executes, the result of the inner loop leads to the outer loop. So totally two loops are executed. After completion of the inner loop, the outer loop is executed. This is called nested loop. The inner loop executes first, then after that the outer loop executes. Concatenated loops means if loop 1, loop 2, two distinct loops. After loop 1 is executed, then only loop 2 is executed. Next, unstructured loop means there is no structure for looping. So this is avoided while we writing the program. So with this, I am concluding the white box testing.